Okay, the final frontier, the final modification for graphing a sine curve. The thing that's new is this plus minus d at the very, very, very end of it. So what this does is it affects the vertical positioning. So plus minus d, this is going to shift vertically. And so what's going to happen here is if I go plus d, that's going to go up by d. What that means, if I go up, so this is related to the amplitude, right? So in theory, sort of a single sine curve would go between 1 and -1. So if you're going up by whatever your d value is, you're just sort of doing plus that. But your amplitude expands it first, and then it shifts up and down. So what's going to happen here is your max is going to be whatever your amplitude is, right? That absolute value for A, plus our d value. The minimum is going to be that negative plus the d. So if you've shifted up, your max and min also get shifted up by d. And then I should have snuck in between your mid value, right, is going to be 0 plus d, right? Tucked in there. If we do a shift down, if it has minus d, that's going to bring us down by d. So that means our max is going to be the amplitude minus d. I'll actually put the mid value in. 0 minus d, right, would be negative d. And then our minimum would be the negative value minus d. So we'd end up somewhere there. Let's run some examples. Let's see if we've got time. This is sort of not a crazy thing to do. This only affects the amplitude. It's not really going to have a gigantic effect. The phase shift stuff, the left, right, and changing the cycle length, I think, is a little bit more involved. Let's try something like, well, let's just do a short one first. I'm going to squeeze it in over here. Let's do y is 4 times the sine. I'm not going to do a shift at all. Let's just do 4 times the sine of x plus 2. This one we can do really fast. We'll do another one that sort of has a little bit of everything involved. Let's just run it in order. So my amplitude, right, is 4 out in front. And then I'm going to shift, in this case, plus 2. So up by 2. So what that means for us now, my max is going to be, right, 4 plus 2 is 6. My middle value, 0 plus 2 is 2. And my minimum would be negative 4 plus 2 is going to be negative 2. So this affects my table, right, as I sort of make my table and put these values in. Again, there's no change here to my cycle length or shifting left or right. So I can just use my normal 0, pi over 2, my normal quadrant angles, pi, 3 pi over 2, and 2 pi. I've got the usual pattern, right? Middle value, maximum, middle, minimum, back to the middle. So what are my middles now? My middles are 2, so 2, 2, and 2. The max is going to be 6, and this minimum is negative 2. So if I make a sketch, let's see if we can squeeze this in over here. I'd like to try to get 2 of these in one sheet. Something kind of like so. So let's say this is minus 2, this is 2, 4, and 6. Something like that. Usual values, pi over 2. This will be pi. This will be 2 pi. So we'll just do a quick version. So our middle values are at 2. So right at 0 and pi and 2 pi, I'm at my middle, which is 2. My max is up at 6. My minimum is down here at minus 2. This would be an interesting thing, right, trying to find the x-intercepts here. What's going to happen, right, as we sort of go up, come down, and then somewhere between these two we're going to cross, dip under, and then come back. So those x-intercepts are happening somewhere in there. We'd have to sort of set this up some way to solve for them. We'll come back to that question. So this for us is y is 4 times the sine of x plus 2. Right? So just a quick shift up. Let's run another one. Let's get a few more things involved. Let's do a shift down. These go a little faster relative to some of the ones. And let's flip it too. So let's do -2 times the sine of 4x, and we'll go down by 3. So this is going to have that flipped, right? Flipped over the x-axis. So the pattern will have changed, right? The max and the mid, or I'm sorry, the maximum and the minimum will sort of have flipped positions. And we're also shifting it down by 3. So let's try to do all this stuff. So amplitude, right? Absolute of -2 would be 2. Down by 3. So my max, right, is going to be 2 minus 3 is going to be -1. My middle value, 0 minus 3, is -3. And my minimum is going to be -2 minus 3 is -5. So this whole curve is going to live underneath the x-axis. This is obviously all three of these are negative values, so this is going to kind of oscillate between -1 and -5. What else is going on here? This 4x on the inside, that's going to affect the phase, right? That's going to affect the length of the cycle. 2 pi over 4, so that's what? Pi over 2. If I take that, right, so then my kind of distance between would be that divided by 4, right? So the whole cycle is pi over 2, and then I'm dividing that by 4. So I'm going to be working with sort of 1/8 pi chunks. Just to save time, I'm just going to sort of make our table, and then you can double check my work to make sure I'm getting these x coordinates correct. But we're not doing a shift left to right, so my hope is that you're right here with me. So we're going to start at 0. We're going to go out to pi over 2. That should be the span of it. And we're going to move in chunks of 1/8 pi. So this is going to be, right, 1 pi over 8. This would be 2 over 8, which would be 1 pi over 4. This would be 3 over 8. This would be 4 over 8, which would be 1/2. So that sounds pretty good. The pattern is off, right? So because this value in front is negative, my pattern here is middle down to the minimum, middle value max here near the end, and then back to the middle. What the heck are these values? The middle value is -3. Let's fill those in first. The minimum was down at -5, and that max is only up to -1. So this whole thing is pretty negative. That's going to affect a little bit how I draw it. By it, I mean my axis. Right, so I'm going to kind of lean towards this sort of fourth quadrant, just to have space here. So where am I going? Between -1 and 5. Let's do 1, 2, 3, 4, 5. +1, and then these guys, right, are pretty small relative to what we're used to working with, but again, we just kind of scale ourselves with what we've got. So I'll just do pi over 8, 2 over 8, 3 over 8, 4 over 8, which is my pi over 2. I'll throw a couple more on here just to make an extension. All right. Oop. Pens are flying. So let's graph it. Let's finish it off. So we've got right? My mid value is here at -3, so that's at 0, pi over 4, pi over 2. This one was inverted, right? It's sort of flipped, so now we have a minimum coming up first, and my maximum here is only at -1. The whole curve is back and forth only here in the negatives. So if I draw it, something like so. And that would be that. So that's y equals -2 times the sine of 4x minus 3. Pretty good graph. Again, I guess at some point I will have said this enough, but Desmos is a great tool to use here because you can graph all of these guys just over top of each other, and it's much clearer to see. If I tried to do it just on the paper, it would get pretty messy pretty quickly. So to try to save you from that, I would say use that Desmos. Try Desmos out. Desmos, great website. I should get a sponsorship. If I get enough subscribers, right, I can monetize. I'll get sponsored by Desmos. Here we go. That's the long plan, I guess.